In this bonus, we will talking about stereochemistry and its relationship with structure of drugs. Stereochemistry, a molecular structure in three dimensions. Stereochemistry is the heart of chemistry. Now, we will talk about the most important parts in this bonus. It's isomers. What's isomer? Isomer, a Greek word, consists two parts. Iso mean the same and mers mean parts. Isomers are different compounds with the same molecular formula. Isomers divided as two types: constitutional isomer and the second one, stereoisomer. Constitutional isomer. They are isomers whose atoms have different connectivity, not back or front. Here are different in rotation. Example: ethanamine and methyl-methanamine. They are the same molecular formula but different in physical, chemical, and biological properties. Stereoisomers. Isomers have the same connectivity but different in arrangement of their atoms in space. Here, front, back, and front. Stereoisomers have two types: diastereomers and the second one, enantiomers. Diastereomer stereoisomer. These isomers are not superimposed, not mirror image. The kind of stereoisomer must be more than one chiral carbon. Enantiomers stereoisomers are not superimposed but mirror image of each other. Enantiomers have one or more chiral carbon. An example, a drug called Timolol. Let's know more about this drug to know more about stereochemistry. Physical properties of Timolol: white, odorless, crystalline powder which is soluble in water and alcohol and is stable at room temperature.
Chemical structure of Timolol consists of two rings, morphine and diazole, and then an oxygen atom which is attached to that diazole ring, and a carbon atom which is attached to another carbon atom, which is attached to hydrogen atom, hydroxyl group, and a chain named N-ethyl to methyl propan to amine. So this is the final chemical structure of Timolol. Timolol chirality. In first we define the chirality. Chiral comes from the Greek word chair, which means hand. Now we're talking about chirality of carbon. Carbon may be chiral carbon or it may be a chiral carbon. Chiral carbon which is connected to 4 different groups, while a chiral carbon which is not connected to 4 different groups. Back to Timolol structure, we have only one chiral carbon, which is this one. This carbon becomes chiral because it is connected to 4 different groups, which are the hydroxyl group, carbon with oxygen group, carbon with nitrogen group, and hydrogen atom. The other carbons atoms in this structure is achiral, means they are not chiral because they are connected with 2 or more similar groups. For example, this carbon achiral because it is connected with 2 hydrogen atoms. Another example is this carbon, it is achiral because it has 3 hydrogen atoms. How many isomers in the Timolol structure? Because Timolol has only one chiral carbon, it has just 2 isomers according to the rule 2n, where n is the number of chiral carbons. Let's know these 2 isomers. The first isomer called S isomer. This isomer has the hydroxyl group of the chiral carbon in the front and hydrogen atom in the back, and we called it S because the hydroxyl group has the highest atomic number
and then the carbon with oxygen, then the carbon with nitrogen, and finally the hydrogen atom, which has lowest atomic number. So it's S, because the rotation is anti-clockwise. On the other hand, we have the second isomer, which is R isomer. This isomer contains the hydrogen atom in the front and the hydroxyl group in the back. We need one shift here, so the rotation will be like this, which is clockwise, so it is called R.
Affecting SR isomers of timolol. R-timolol, which is less active and thus are not used as a therapy. S-timolol is more active and thus is used as a therapy. Beta-adrenergic blockage agent. S-isomer of timolol, also called timolol-molate. So for the benefits of knowing chirality and separation of isomers: increased receptor selectivity and potency, decreased adverse effects, decreased dose given to patients, decreased potential drug and drug interaction, increased safety margin, high therapeutic index. So stereochemistry called heart of chemistry.
Structure of S-timolol-molate. Now we will explain about S-timolol-molate. Structure of S-timolol-molate. The timolol has molecular weight 316 gram per mole. We will say structure of S-timolol-molate in 3 dimensions with movement now. We have in this structure 5 different colors for 5 different atoms: carbon, hydrogen, nitrogen, oxygen, and sulfur. The carbon atoms appear in green color. Timolol has 13 atoms of carbon. The hydrogen atoms appear in pale blue color. And we can say hydrogen atoms appear and disappear and linked to oxygen, nitrogen, and carbon atoms. Timolol has 24 hydrogen atoms. The nitrogen atoms appear in blue color. Timolol has 4 atoms of nitrogen. The oxygen atoms appear in red color. Timolol has 3 atoms of oxygen, and sulfur appears in yellow color. Timolol have 1 atom of sulfur gas in its structure. Now we say timolol in line formula or solid formula, and we can see single bound and double bound. Timolol has chiral carbon. Chiral carbon has 4 different groups linked to it, so that is chiral. The remaining carbons achiral. The absolute configuration is S. It is mean anti-clockwise rotation.
The warnings of this drug. Don't use Timolol drops if you have severe chronic obstructive pulmonary disease or a history of asthma. Don't use Timolol drops if you have heart block, heart failure, or unusually slow heartbeat. Don't use Timolol drops if you are using another beta blocker eye drop such as betaxolol.